Well, I'd like to welcome you back. Very exciting today. We're going to move away from Unit 3, which you may remember involved all that mole business and stoichiometry, percent composition, limiting reactants, and we're going to shift into maybe a little more hands-on unit that I can actually do from my own home, because a lot of the things we'll talk about are actually in the kitchen or in your workshop. And really that's what's so great about chemistry. It's all around us. And that unit is on solutions and solubility. We've talked a little bit about solutions and solubility earlier in the course. In this unit, we're going to look at the types of solutions. We'll take a look at how to make a solution and how to dilute a solution. And then later on, we'll talk about specific solutions such as acids and bases, some review of grade 10, you may remember, and looking at it quantitatively, and dare I use that word, stoichiometry again. Yes, we will revisit that concept and get into that, especially when we look at acid-base neutralizations. So just a very brief introduction. Firstly, you'll remember from your elementary days maybe that a solute is really the substance that gets dissolved when you prepare a solution. I think many of you made salt solutions or sugar solutions in elementary school, and you dissolve stuff together with a spoon or a stirring rod or something like that. The solvent, usually water, but not always, is the dissolver. It's a substance that does the dissolving. And I've got a few demos here that I'll show you today. Things that I've pulled from my own home, and I do have a little bit of chemical glassware here. And we'll look at the types of solutions. Well, firstly, gas might be the type of solution that you least think of, but really the air around us is a solution because it has one visible phase. And the air that we breathe is about 80% nitrogen, around 20% oxygen, and there's little bits of CO2 in there and other gases like argon and neon, etc. So we're not going to talk a lot more about gas solutions, but they exist because they're one-phase mixtures. Another example would be a liquid solution. And the example I've got here is methanol and water or antifreeze. Maybe some of you are working on getting your G1s. You're able to drive a little bit. Scary thought. And winter has passed, but in the middle of winter, sometimes it's nice to have some de-icer in your car to clean off the windshield when it gets icy. Well, this is just methanol and water. And it's been colored so that the kids don't drink it necessarily, otherwise it will look just like pure water. It's a solution. This is quite deadly, by the way. If you drink it, it'll kill you. So you don't leave this around where small kids are, and it does have a child-proof cap on it. So good example of a liquid solution. Obviously, ethanol and water would be another example. Another type of solution that we can deal with is a good old liquid-solid solution. So this is the one that you may remember from elementary. You have your salt and you have your water, and voila. You stir them up. Obviously, we can see that it takes a little bit of effort, but salt and water, quite an easy solution to prepare. Salt is very soluble in water, right? We know from earlier in the course that group 1 ions like sodium are always soluble. So very easy to make a salt solution, isn't it? Sugar and water, another good example. So that would be a good example of a liquid solid solution. The last one I want to talk about here is the solid solution, and we call these alloys in some cases. And it may be the one that you're not thinking about too often as well. Well, nobody wants to eat their meal with a rusty utensil. Nothing worse than that. So stainless steel has provided a lot of convenience for us in the modern era because it doesn't rust. It resists oxidation. You may not have thought about it, but when you analyze this solution more closely, it is made of iron, but it's also made of nickel and molybdenum and titanium. And there are different degrees of stainless. It depends on the kind of stainless you buy. Some are better than others. Some are harder than others, and some resist oxidation or corrosion more than others. So your forks, your knives, and even the spoon that I prepared that salt solution with arguably are solutions because they are one-phase mixtures. Solid, solid. One other example, this is a relic that I've got. You don't see these things anymore too much in circulation. This is an old-fashioned fire extinguisher. To be honest, the chemicals that used to be stored in these things were cancer-causing, carcinogenic, carbon tetrachloride. This is empty, but it's a pure brass solution, really. And brass has that property that allows it to be very beautiful and hard at the same time. So it resists corrosion and it looks good. And so brass, to be honest, is a mixture of copper, zinc, and tin. And a lot of our home decorations might have brass in them. Everything from picture frames to lamps in your living room. If you look around, you might see those kinds of solutions not too far from where you are even now. So that's a very quick look at solutions. The other thing that we can easily do, which you already learned about, is to talk about a concentrated or a dilute solution. So very simple little experiment. If I take my food coloring, and what the heck, let's pick blue because we are all blue and white. If you take that and mix it, you can see that this solution is fairly concentrated, isn't it? That's a dark blue solution. So we in chemistry, we do talk about the terms concentrated, and when you hear the term concentrated, obviously that means there's a lot more solute dissolved in that solvent. So this would be a concentrated solution. On the other hand, we oftentimes look at weak solutions as being dilute. And that can be done quite easily. I've got a graduated cylinder with water, and if I take a little bit of my concentrated solution and I pour it into my cylinder and try to mix it, not the easiest thing to do, then you can see that this new solution that I just prepared is obviously more dilute than the original. So dilute solutions do not contain as much solute per unit solvent as a concentrated. Later on in this unit, we'll actually figure out how to prepare dilute solutions from concentrated ones using the good old mole. And then that will lead us into stoichiometry, which again uses a good old mole and stoichiometry. So there it is. That is a very quick introduction to Unit 4, Solutions. We'll be looking at chapters 8, 9, and 10 in your textbook. I'll try my best to use my kitchen and my workshop and pull things in just to make it a little more lifelike as we go through. I hope this helps. We'll next time start looking a little more deeply at how to prepare these wonderful solutions.